Before we get into some examples, let's look at, once again, the major parts of a quadratic function. The vertex is going to be the minimum or the maximum value. These things match each other. For example, this is the vertex of this quadratic function or parabola, and our vertex is right here for this one. This vertex is a minimum, and that's because the a value is positive, which makes it open up. This vertex is a maximum because the a value is negative. And if you remember, when we're talking about a, b, and c, we're talking about ax squared. Wow, what am I doing there? Let's try that again. Ax squared plus bx plus c equals 0, or y in the case of our problem. Now, the reason why we care about the vertex is because through the vertex is the axis of symmetry, which means values that are equidistant from the axis of symmetry must be equal to each other, and that's by definition of a quadratic. If they're not equal, it's not a quadratic function, and that can happen for positive or negative values if we're passing through the axis of symmetry. And finally, the domain and range. The important parts here are the domain, because it comes first in the alphabet, covers the x's, because the x's come first in the alphabet, and the range is going to cover the y's, because the y's come second in the alphabet. So let's do a couple quick examples here. So what I have here is a quadratic function. Now, it's written a little bit differently than our ax squared plus bx plus c form, because there is no b term in the middle. We can still do our a, b, and c values, though. We just have to be a little bit sneakier about our b value. So the a value is the value in front of the x squared term, which in this case is 1, if we're using Ann's method. Now, the b value, this is going to be a very common mistake, is the b value is 0 in this case, because there is no anything times the x term. So what we really have is we have plus 0x floating around in the middle of this equation. So the b value is 0, which makes the c value a negative 4. And if you bring this up to me right now and explain to me that when the value is missing, that would make the coefficient a 0, you can get 5 SPs. Now, once we have the a value, the b value, and the c value, we need to find the vertex first. And the vertex, the x value of that, is always equal to the opposite b over 2a. Well, this one's going to be pretty easy to find because the b value is 0. The opposite of 0 is 0. And it goes 2 times 1, because the a value is 1, which means the x value is 0. So our axis of symmetry is right along here. Now, the reason why we want to find that is it creates the middle of our table that we're going to use to find the rest of our values. And because the x value is 0, that means we can do the table, whoops, that's not right. The table that we used to do all of the time for lines is now a good table here. -2, -1, 0, 1, and 2. Our vertex is here. In this case, it's going to be a minimum because our a value is positive. And then these numbers should match. And these numbers should match if we do everything correctly. So let's try it out and see what we get. Our 0 value here would be 0 squared minus 4. Well, 0 squared is 0. 0 minus 4 is -4. And so if we did everything correctly, this should be our vertex, and it should be opening to the left and right. So let's check to see if that worked. If I go -1 squared minus 4, that's 1 minus 4 is -3. Here, if we do this for 1, we get 1 squared minus 4 is also -3, and that tells us that our vertex has to be correct because we are equidistant away from our vertex on both of these values. To finally check our last one, we do 2 squared minus 4 here, or negative 2 squared, in parentheses, minus 4 on this side. And so we create 4 minus 4 for both of them, which is 0. So we have our quadratic here. Drawing lines is so hard with this board. There we go. And they're very sloppily drawn, is our quadratic function for this problem. So once again, you want to find the vertex, make the middle of your table equal to your vertex, and then graph equidistant from that point. So let's do one more problem here. To keep it short, we're going to cut the middle part short. But for now, we need to find the a value, the b value, and the c value before we can find the vertex. Our a value here is negative 2. Our b value is negative 2. And our c value is positive 2, which means our vertex has to be equal to opposite b over 2a. Our b value is 2, so that'll be positive 2. 2 times a would be 2 times negative 4. So I get 2 over, whoops, that's a 2. So equal negative 4 there. I jumped the gun a little bit. Or negative 1/2 as the center of our table. And we see fractions. Some of us might panic because we are middle schoolers after all. But the fractions are actually not any different than what we've been doing, because we put the negative 1/2 in the middle. And we want to pick points that are equidistant away from a half. Well, a negative 1/2 is just halfway between 0 and negative 1. And then I can put negative 2 here and 1 here. And then once again, our vertex is the middle. So then these points should match. Whoops. And then the points here and here should also match. Now, I'm going to pause this video to fill out the table to save us a little bit of time. Many of us might have struggled with the vertex portion here because we're dealing with some pretty intense fractions. But you can write this as positive 2.5, or you can write it as 2.5 as a decimal. Both are going to be correct. But what's important is that I know that I'm correct because this point and this point end up matching. And negative 2 and 1 end up matching as well. And the thing about a quadratic is that if these points match out here and these points match in here, you have to have found the vertex. It's one of those types of problems that will eventually double check itself. Hopefully that you're better at drawing it than I am. Now, real quick at the end, we're going to talk about our domain and range again. Now, in this case, our domain, once again, we can pick any x value along this line. It's going to get pretty crazy if we pick really big or really small numbers, but it is all real numbers still. But our range is restricted to numbers that are smaller than 2.5, because this is our maximum, which means that it's all real numbers that are 2.5 or smaller. And you could write that once again as, in this case, you would go negative infinity and then positive 2.5 this direction. Okay? Not an easy concept. We can't get through a lot of examples, but you see here that we take some time, so the assignments will be a little bit shorter than they have been in the past. But as always, if you have any questions, please let me know.